So in my FS1 2021 paper walkthrough that's on my channel, I did a very poor job of explaining the last question, which is this question here. This is relevant because they asked a very similar question, although I can't show it currently, in the 2022 paper. So if you are preparing for the 2023 papers, I'd recommend you have some way of dealing with this. And hopefully this video is going to make it much more clear how to do that, because I explained it really badly in the previous one. Anyway, we've got a manufacturer and manufacturing stuff. We have an unknown mean and a standard deviation 0.2. This person believes that it's not working properly and the mean has decreased, so he's doing a one-tailed test. Null hypothesis is the mean is 15, and the alternative hypothesis is that it's less than 15. Okay, write down the size of this test. Well, the size is just the probability of rejecting H naught when it's true, which of course is just this 0.01, the probability being in this area here. So that's just 0.01 based on the level of significance. That's just what that is. That's a nice, easy mark to start off with. Given the actual value is this, and now this is where it gets interesting, and this is where I'm going to try and explain this much better. But essentially, this is the picture you need to have in your head. So this is a double normal distribution graph. We've got one here and we've got one here. I'm going to explain why this is going to be helpful in just a second. First, we'll deal with the first bit here. So we've got a sample here. So X is going to be normally distributed. The sample mean of X is going to be normally distributed with a mean of 15 because we'll currently accept the null hypothesis, and then the variance here is going to be 0.2 over root n all squared, which I can write as 0.2 squared over root n all squared is just n. So okay, that's that there. And now this normal distribution here is going to be represented by this red normal distribution here. So the mean is 15, and what we're going to look for is we're going to look for the k value such that we have 0.01 area beneath it, like we said here. So we're going to look for the critical value k, such that below we would reject h naught, because we're in this 0.01 region, and above we would accept h naught because we're in this region here. So to do that, of course, we're just going to standardize it. So we're working with this distribution. So it's going to be k minus 15 over the root of this, which is 0.2 over root n, equals, and now get out your calculator or use the tables, it doesn't really matter, inverse normal area 0.01, because of course we want this area to be 0.01 here, just underneath this red graph. Mean 0 sigma 1, of course the standard normal distribution there, and we get this value here as going to be the value that we need to get to, times this across, and add 15, and we end up with this here. So okay, that's our critical value of k. We don't know exactly what it is because we don't know what n is for this size of the for this sample, but we'll just leave it there. And now this is where this graph comes in. Because actually what it says is the actual value of mu is 14.9. And that's what this normal distribution is saying, is that the mean is actually 14.9. And the probability of a type 2 error, now a type 2 error is accepting h naught, but h naught is false. Now what that means is we live in this black distribution here, but we're above k. Because remember what we were saying here was being above k means we accept h naught. That's the whole point of k, is below k you reject h naught, and above k you accept it. So we're living in this black distribution, but we're above k. That's how we get a type 2 error, right? Is because we're above k, so we accept this, but we're actually in here. Accept h naught, but h naught is actually false. We're actually in here with a mean of 14.9. So we want to be in this little area here underneath the black graph. And we want that area to be less than 0.05. So again, what we're going to do is we're going to do another standardized normal distribution thing here, but this time we're going to standardize it against the black graph because that's where we actually are. So it's going to be k minus 14.9 this time because we're in this graph here. So k minus 14.9 over this same thing because it's the same 0.2 over root n that we had before because the sample size isn't changing. But we need to be now above, because remember, we need to be in this black area beneath this black graph here. We need to be above this thing, so we're going to be greater than the standard value when you standardize this. So of course, inverse normal, 0.95 this time, because we want to be way over on the right-hand side of a normal distribution over here. Mean 0 sigma 1, and that gets us this value here. So we want to be above that because we want to be above k, as we've said, to accept h naught, but this is going to lead to our type 2 error because we're actually in here. So that's why we need to be above this value here. And now the entire question, once you've set up that, is just algebra. Because we, of course, multiply this thing over here, I guess, is probably what I did. I don't even know what I've done here. I think I've multiplied this across here and then also replaced this k with all of this stuff. So yeah, this k has been replaced with all this to go here. And then this is just multiplied across here. These two terms go together. This obviously goes together with that. And then you times this across, divide by this, and you end up with this, which means n is 64, I guess, is the least value you need to select. But this is the key picture you need to have in your head for these type of questions. This is this double distribution graph, with one of them representing the null hypothesis and the other representing what's actually going on. Again, a very similar thing was asked in 2022. However, I can't show it on the channel right now. Just to finish this question off, he now carries the test at 5%. He changes this test to 5%. Now, what's that going to mean? Well, originally, of course, we were talking about how this area down here is 0.01. Because of this, if it changes to 0.05, of course, that moves k along to the right, because this area to the left of k needs to be bigger, right? So k moves along to the right slightly. But of course, in the act of k moving on to the right, that means this area we were talking about for a type 2 error, that's decreased, because the type 2 error was this area under the black graph. But if k has moved to the right, that means you've got lesser area there. And so this probability decreases if you do that. Anyway, I hope that explained it more clearly, and thanks for watching.